All right, now that we've got our buttons down here at the bottom, we should make them do something other than just say start and stop and etc. So down at the point where I call the step event, what I'd like to do is actually start the whole simulation. I'm going to create my own method, which I'm going to call here in the step event, and it's basically going to do one step of the simulation. So I'm going to create my own method, which I'm going to call step. Now notice that I have a button called step right here, and I have a method called step. They're named the same thing. The way that Java can tell the difference between a variable and a method is just if there are parentheses after it. So since this guy doesn't have parentheses after that, it knows that I'm referring to the variable rather than this method. So in here, when I actually want to call this method, I'm going to do this. And that means, because there's parentheses afterwards, use the method itself. All right, so what am I going to do in a step? So this is where I need to go through all of my cells and see how many neighbors they have. So to begin with, I'm going to start with for loops that are going to at least walk through each of my current cells. So I can do something like the rows and columns that I did in the life panel. So I'm going to say for, let's see, I want to start at row 0, and I am using for rows the cell's length, and then for the columns I'm going to use cells 0's length. So this is the first dimension, this is the second dimension that I'm referring to here and here. It's possible I could create a grid of 20 by 10, and then the length of the two things would matter. All right. So now that I've got a particular one of these things, what I need to do is count up the neighbors. So I'm going to create an integer which is going to keep track of that. Neighbor count starts at 0. So the first thing I'd like to do is I'd like to check the neighbor that's to my left and up from me. So if cells row column, except I want to check one left from me, -1, -1 is true, then I need to add 1 to my neighbor count. And this is going to be up and left. Now there's a slight problem here. If I am at the 0, 0 spot, when I try and go to the -1, it's going to throw an array out of bounds because I've gone to the left of my grid. So I need to make sure that when I'm going that direction, I check to see if my row is non-zero. Because if I go to the left in any of my 0 row, that's going to be an array out of bounds exception. I will get my lovely error and the game will be over. So I need to check row is greater than 0. One thing that Java does is it's something called short-circuited AND statements. What this means is that if row is greater than 0, it doesn't bother checking the rest of this, because if you have an AND statement, both parts have to be true, or else the whole thing is false. So if this left side is false, we don't need to bother checking the right side, which is good because if I did check the right side, I would get an array out of bounds exception. So if it is equal to 0, it won't bother evaluating this array, and it won't get an array out of bounds exception. I also have to worry about this column here, so I'm going to do that as well. So I got to make sure that I'm within those bounds before I actually check to see if that's true. Next, I need to check, let's say that I just check up. So I need to make sure that row is greater than 0 again. And then I'll check row -1 and just column. So if I'm going to create a little diagram of the how this is going to work. If I'm looking above and left, that's going to be row minus 1, column minus 1. Above me is row minus 1, column. This will be row minus 1, comma, column plus 1. Let's see, to the left is the same row, but it's still column minus 1. This is the one I'm actually looking at. That's me. Row, column plus 1. This is row plus 1, column minus 1. Row plus 1, column. And row plus 1, column plus 1. So those are the neighbors I'm going to be looking at. This is if I'm this cell here, my neighbors are these coordinates within the array. So I need to check all 8 of those and see if any of them are true. Once I do that, then I'm going to add 1 to the number of neighbors. So this one is up. So now, assuming you put in the other 6 if statements, we should have an accurate neighbor count. So here, we now need to do the rules of life. So if I am alive, so that means that cells row column is true. I'm alive. Then the way that I figure out next round whether or not I'm alive or dead is I need to check to see if I have 2 or 3 neighbors. So if neighbor count is 2 or neighbor count is 3, then I'm going to stay alive. Now, I don't have anything for the next step. I should do that real quick. So I'm going to call this next step for next cells. Maybe that's better. Next cells. And that's going to be a new Boolean array, which is cells for the row and cells 0.length for the columns. And what I'm going to do is I'm actually going to update next cells. I don't want to update my current cells because I need to go through and make sure I update the counts for every single cell before I alter them. Otherwise, what would happen is I'd be changing the neighbor counts of the rows below me as I went, which is no bueno. So what I'm going to do is I'm going to actually update next cells, row, column. So if I'm alive and I have 2 or 3 neighbors, I'm going to be alive next time. If not, that means I have 1 neighbor, or I have 0 neighbors, or 4 or more, all of which mean death to me, row, column. Dead next time. Okay, so if I have that, now I need to have the part where what happens if I'm currently dead. So the only way I come back to life is if I have exactly 3 neighbors. Then I'm going to be alive next time. If not, well, I remain the dead. Alive or dead, no zombies here. So that's the basic rules of life, and I'm basically setting up all of these next cells for the next time through. So once I have all of these neighbor counts done, and I have these rules of life, my next cell's Boolean array will be correct. Now the problem is that I need to update cells, and not just in life, but also in life panel. So once I get done with these loops here, which is right there, which matches, I need to update cells, which I can do with just that one line. But I also need to update the life panel array. So I don't have a way to do that right now. What I'm going to need to do is put in something that does that. So I'm going to create a method void set cells. And what I'm going to take in is a Boolean array new cells. And I'm going to set cells equal to new cells. So now what I can do is I can pass in a Boolean array using the set cells method for a life panel, and it'll update this guy. So in here, in my life, the way I get at that is I say panel.setCells, and it'll update that now. And then the last thing I should do is I should repaint my frame so I can actually see this updated thing. Notice I have, so what I pass in is this thing I called next cells here. When it goes into life panel, it gets renamed new cells, but it's pointing to the same thing, but it's still next cells from life. And then it gets assigned to this internal cells variable. Now something that's subtly going on here, the previous cells that I had, nothing is pointing to it anymore. And so if you were in C++, you would care about that because you'd have a memory leak. In Java, Java will actually take care of that. If you start running low on memory, it'll remove all of these extra things that are hanging around in memory. This original cells Boolean array, since it's no longer in use, it can be garbage collected, is what it's called. So that particular thing gets garbage collected. Okay, so now that I have all of these step things, does it work? First of all, I need to put in all of the rows and columns, and then I will check that out.